Hello students, welcome back to our channel Diksha Karnataka. So as you know, we have already released the mock test 4. So the solutions of this mock test for chemistry will be discussing the part 1 where it will consist of question number 1 to question number 30. So if you haven't got this question paper, the link of the WhatsApp channel is there in the description section. Go there, download the question paper and then solve it. Okay. So I'll be explaining each and every questions, and I'll also tell what was the difficulty level and what was the right approach to solve these questions. So now let us begin with the first question. Okay, so question number 1 is from your organic chemistry, general organic chemistry. Very easy question. Hyperconjugation is not possible in. So first of all, you should know what is the condition for hyperconjugation. It should have an alpha hydrogen. So you can see here, this is alpha hydrogen is present, here alpha hydrogens are present, and then we have alpha hydrogens present in option D also. But if you see the structure of option B, here we don't have any alpha hydrogen present, right? So the correct answer for this question will be option B. Next. When hydrogen chloride gas is treated with propene in presence of benzoyl peroxide, it gives what? So you have this propene. Now when you treat it with HCl, we should get a more stable product formed, right? So what will happen here? This chlorine can either attack on this carbon or can attack on this carbon. This is a secondary one, this is a primary one. We know secondary is more stable. So chlorine will attack on this carbon. So the product we will get is 2-chloropropane, right? So correct answer for this question is option A. These are all from your basic organic chemistry. Next. Okay, again highest boiling point. This question is from hydrocarbon chapter. First year topics these are. So you have to just know the basic things of this first year chapters. So first of all, which of the following has the highest boiling point? So we know for boiling point there are two factors. Okay, boiling point is directly proportional to mass and is inversely proportional to branching. Means if the mass is more, boiling point will keep on increasing, and if branching is increasing, then boiling point will keep on decreasing. So now you can see there is no branching in these compounds. So let us see, first of all we have this one is 3 carbon and this one is 4 carbon, right? And these two compounds are branching, so we did not compare these two. You can see if you draw the structure here, this is like this, right? So we have a branching here. So once branching is there, boiling point will definitely be low. So no need to consider option C and D. Now if you see option A and B, B is having more number of carbons, more is the mass, more will be the boiling point. So the correct answer for this question is option B. Okay, next. Which of the following forms propane nitrile as the major product? Okay, so propane nitrile means what? We have this one. This is propane nitrile, and we know we should take now 2 carbon. Okay, 2 carbon, any RX you will take. If you add it with KCN, so that will give you CN, right? So now you see if you take ethyl bromide and KCN, propyl bromide if you take and you add KCN, one more new CN will add, and the product will have 4 carbons. But in the product we need 3 carbons. That means in the reactant it should have 2 carbons, right? So from that we can eliminate these two options. Now you know for adding KCN, for adding CN group, we need the reagent KCN and not AgCN. So the correct answer for this question is option A. Okay, next. Okay, from ethers we have this question. Which of the following, among the following ethers, which one will produce methyl alcohol on treatment with hot concentrated HI? Okay. So for getting methyl alcohol, see, this is the cleavage of ethers. The topic is cleavage of ethers. See here, if this bond breaks here, we'll get a cation here. This is very stable cation, 3 degree, and in HI we have H plus and I minus. So the I minus will attack on this carbocation. So we will get the product here as this one is I plus CH3OH, right? So the correct answer for this question will be option A. Okay. Next. Phenol when treated with excess of bromine water gives a white precipitate of. So this is one very common reaction. So we have phenol and we have this bromine water. Okay. So if you treat it with this one, we will get 2, 4 and 6 bromine. Okay. So from this you can remember one thing, you can just note it down, this is a white precipitate. Okay, so if you give that ABCD type questions, if you get, so you should know like white precipitate the compound forms, that we have to remember. So the correct answer for this question is option A. Next, okay, vapors of an alcohol X when passed over hot red copper produced an aldehyde. So this is again from aldehydes chapter, very important reaction. If you take primary alcohols, we will get aldehydes. If you take secondary alcohols, we will get ketones, right? This we have already, this is there in the reactions of oxidation of alcohols. So if you can see, if it is giving you aldehyde, it must be a primary alcohol. So the correct answer for this question is option A. Okay, next. Benzoquinone is produced by reaction of phenol with. Direct reaction based question, again from alcohols phenols chapter. So you have benzene, you have to just oxidize it in presence of Na2Cr2O7 and sulfuric acid. The product will be benzoquinone. Okay, if you remember the structure of benzoquinone, so this is the structure of benzoquinone. Okay, reaction based direct question, easy one. Next, which of the following is the most reactive isomers? So again a question from aldehydes and ketones chapter. So if you see, aldehydes are always more reactive than ketones. We have two reasons for this one. First is your electrophilicity of carbon and next is your steric reasons, right? So you can see option B is a ketone, C is a ketone, D is also a ketone. Option A is an aldehyde, so obviously A will be more reactive. So the correct answer for this question is option A. Okay, next, identify the products X and Y in the major reaction. Okay, so this is your, if you can see, this is Friedel-Crafts acylation. So if I add this one, first we will get COCH3. So we will get the product here after Friedel-Crafts acylation as COCH3, right? So this is the X. So you can see from here we can eliminate option B and option D. So now let us see option A and C. You have taken concentrated H2SO4 and concentrated nitric acid. This is the reagent for nitration. We have studied this reaction from the first chapter, haloalkanes chapter only, it is there. So now if we do nitration here, what is the point? You have to remember whether it is on ortho para directing or a meta directing. So COCH3 is an electron withdrawing group, right? So it will be meta directing. So we will get NO2 at this position, right? This is ortho position, this is meta position. So we can see both the options now, meta nitroacetophenone. So the correct answer for this is option A. So this question can be a little tricky if you don't know like what is, whether it is electron withdrawing group or electron donating group. Okay, next, which of the following compounds undergo Cannizzaro reaction? Again from aldehydes chapter. So what is the condition for Cannizzaro reaction? It should not have any alpha hydrogen. No alpha hydrogen should be there. So you can see the structure in this compound, we have an alpha hydrogen here. So in this structure also we have 6 alpha hydrogens. But if you see this structure, benzaldehyde, it doesn't have any alpha hydrogen, right? So the correct answer for this question is option C. So there are another compound, formaldehyde and benzaldehyde, which undergoes Cannizzaro reaction. Next, which of the following compounds would have the smallest pKa value? Okay, so this here also little trick is involved to know the relation between acidity or acidic strength. See, if acidic strength is more, okay, then pKa value will be less, right? So they have asked you smallest pKa value, that means we have to calculate the, or we have to find out the strongest acid among this. So how to find the strongest acid? What's the condition for strongest acid? For strongest acid, the conjugate base should be stable, right? Conjugate base should be stable. So now if you see this part, here after getting, here we will get a negative charge on this after H plus is released. Here if you see, here we'll get a negative charge, here negative charge and here negative charge. Now what is the stabilizing agent, or what is that can stabilize this conjugate base? So the presence of fluorine, which is an electron withdrawing group, can stabilize this conjugate base. So fluorine will have minus I effect, right? Fluorine can stabilize by minus I effect, which is distance dependent, right? Minus I effect or inductive is distance, it depends on the distance. So now you see here fluorine is nearest to the conjugate base, so it can withdraw better and can stabilize the conjugate base. So the highest or the most acidic one will be option B. Because it is most acidic, its pK value will be the smallest. Okay, next question. So this I can tell you little tricky. You have to understand application based question, not very direct, okay, but easy one. Next, okay, Hinsberg reagent, we know tertiary amines do not react with Hinsberg reagent, so option C will be the correct answer. Okay. Next, the action of nitrous acid on an aliphatic primary amine gives. So this also you should know. If we have primary amines and you treat it with nitrous acid, product forms are alcohols. Okay, direct reaction based question from the amines chapter. The correct answer here is option C. Next question, we have question number 15, where you have to tell the order of the basicity order. Okay, so you have been given with 3 structures, orthotoluidine. So we have this group NH2 with methyl group in the ortho position. Then we have aniline group, and then we have orthonitroaniline. Okay. Okay. So here this question is important one because it has one concept which we don't remember easily. Now see here, nitro group, you know, electron withdrawing group is present. So if electron withdrawing group is there, basicity will decrease, right? So if basicity decreases, this one will have least base, it will be less than aniline because aniline doesn't have any electron withdrawing group. Now, but if you see methyl group, it is in plus I effect, okay, but this is present in ortho position, right? So there is one concept which is called as ortho effect. If you remember, what does it say? If any substituent is present at the ortho position, it decreases the basicity, right? So that is why the highest basicity will be aniline and these two will be less than that. So the correct answer for this question is option B. Okay. Next, the anomeric carbon in glucose. So if you remember glucose structure, anomeric carbons, anomers are those isomers which differ in configuration only at C1 position. So the correct answer for this question is option A. Next, fibrous protein, you should know what is the bond that is between them, that is hydrogen bonds. So the correct answer for this is option C. Next, a unit in nucleic acid. So this is very important one, you should know the basic things. So if we have a sugar, so okay, let us see here, DNA or any nucleic acid, it is made up of what? If you see, nucleic acids are made up of nucleotides. Okay, and nucleotides are made up of 3 things. We have sugar, okay, and then we have phosphate group, and we have a base group, right? This sugar group and phosphate group together forms one unit called as nucleoside, right? So the question here is a unit in nucleic acid which contains the base sugar and the phosphate group. So we have sugar and the phosphate group, so that is called as your nucleotide, right? Okay, next question. So if the question would have been only base and sugar, then the answer is nucleoside. When it is base, sugar and phosphate group, it makes your nucleotide. Next, which of the following complex has minimum magnitude of delta O? Okay, minimum magnitude means the splitting of d orbital is less. So we know the ligands are of 2 types. We have 2 types of ligands. One is strong field ligand and another is weak field ligand. So if it is a strong field ligand, splitting will be more. If it is a weak field ligand, splitting will be less. So you can just see the options and check whether they are strong or weak field ligands. Coming to option A, CN is a very strong field ligand, so that cannot be answered. Splitting will be more in that case. NH3 is also a strong field ligand. Here also splitting will be more. Then if you see here, chlorine is a weak field ligand, right? So in case of chlorine, the splitting will be less. Then water is a stronger field ligand than chlorine. Okay, so the correct answer for this question is option C. So what you have to remember here, the spectrochemical series. Okay, that series you have to remember. So then you can, so it is little confusing to decide between chlorine and water molecule. Okay, so but you remember halogens are the weakest ligands. Next, Okay, this is very good question. The two isomers X and Y with the formula is given to you were taken for an experiment on depression of freezing point. It was found that 1 mole of X gave a depression corresponding to 2 moles. That means what? X molecules, whatever the compound X was there, it was dissociating to give you two ions were produced. We have studied this under Van 't Hoff factor. Okay, next. And 1 mole of Y, if you take 1 mole of Y, it was dissociating to give you 3 moles, right? So, okay. So now you have to check in these options which are those compounds which will give you X, 2 ions will be forming, and for Y, 3 ions will be forming, right? Okay, so now we will check for each and every option and then we will see, compare the answer, okay? So let us go to the first option. You see here, if I break this compound, this whole complex will be 1 ion and there are 2 bromine ions here. So for option A, X will produce 3 ions and Y will produce, this whole compound will give 1 and this one will give you 1. Y will produce 2 ions, right? Okay, next question number, if you see option B, here this one will give you 1 ion, this one will give you 2 ions, so total 3. But according to the question, X is giving you 2 ions and Y is giving you 3 ions. So we can say option A is also wrong, option B will also be wrong. Now if you see option C, this whole complex is 1 ion, bromine is 1 ion and chlorine is 1 ion. Again, this is giving me 3. And if you check here, this whole complex is 1 ion and bromine is 1 another ion, so that is 2. Now see option D. Here we have one complex, 1 ion and chlorine another ion, that is 2. You need not consider the water molecules, okay? Okay, we can see here option B also. This water molecules will not be any ion, so this whole complex is 1 ion, okay? Now if you see this side, here this complex is 1 ion and 2 bromines are another 2 ions. So total we are getting 3 ions. So you can see X on decomposition, on dissociation is giving you 2 ions and Y on dissociation is giving you 3 ions. So the correct answer for this question is option D. Okay, next. Okay, so this is one, what we say, this is a theory based question. Platinum dissolves in aqua regia to give you H2PtCl6. So in the D block chapter, you can just see some important reactions are given in D and F block. So the question is from that part, H2PtCl6. Okay, next. So we have, okay, here the question is in FeCO5, Fe to CO sigma bond results by the overlap between filled sp orbitals of C atom of CO and the vacant. Okay, so to answer this question, first of all, you see there are 5 ligands, right? So what can be the structure of a 5 ligand? We have 5 ligands means the structure is generally trigonal bipyramidal, okay? I think you remember this one. Now, another way to check is, see, if there is 5 ligands, the orbitals, there should be 5 hybrid orbitals. So in D2sp3, how many hybrid orbitals will be there? 1, 2, 3, 4, 5, 6 hybrid orbitals will get. But we need only 5 hybrid orbitals. That also we'll see for sp3. In sp3, we will get 4 hybrid orbitals. Right, I'm just adding these numbers. 2 plus 1 plus 3, that is 6. Here 1 plus 3, that is 4. Now if you add this one, 3 plus 4 plus 1, 5 hybrid orbitals. Okay. Then here if you see 2, 3, 4 hybrid orbitals. Right. Now if you see, if you don't know this part also how to do, I'm telling. So you need 5, there are 5 ligands, you need 5 vacant orbitals and you are getting 5 hybrid orbitals in option C. So the correct answer for this question will be option C. Okay. So little this one is difficult question, I can tell, if you cannot identify this part. Next. Okay, the acidic, basic and amphoteric nature of the oxides are given to you. So you know higher the oxidation state, more is the acidic nature. And this table you have to remember at least 2-3 examples you should remember. And V2O5 is a very common, everyone must be knowing, it is an amphoteric oxide. So we can eliminate option A and option D. We are left with option B and option C. Now in Mn2O7, what is the oxidation state? If you calculate, this will come +7, right? +7 means higher oxidation state, it is more acidic. So the correct answer for this question is option C. Okay, next. the catalytic activity of transition metals and their compounds is due to. So this question is from transition metals, right? The ability to adopt various oxidation state, their chemical reactivity, magnetic behavior, their unfilled d orbital. See, this option D can also be a reason, but you have to find the most appropriate answer. So the most appropriate is their ability to adopt to variable oxidation state. So the correct answer for this is option A. Okay, next. Titanium compound that does not exist. So what is the oxidation electronic configuration of titanium? We have, sorry, for titanium it is 2122, right? So it is 3d2 4s2, right? So you can see the maximum oxidation state titanium can show is +4. Okay, so here what's the oxidation state of titanium? If you take TiO, it is +2. Here in TiO2, it is +4. Let us calculate for this one, K2 TiF6. So I can write 2, for K2 it is 2, then X minus 6 is equal to 0, X is equal to +4. So here also titanium is having +4 oxidation state. Now if you calculate this one, this is 2 plus X minus 8 equal to 0 and X is coming to you +6. But titanium can maximum has +4 oxidation state. So the correct answer for this question is option D. Okay, next. For which one of the following metals the standard electron potential has a positive sign? So this is a theory based question. You have to remember one and only element, copper, is there whose electrode potential is 0.34 volt and it is a positive potential. Okay, so the correct answer for this question is option A. So this you have to remember, hydrogen is 0 and copper is 0.34. Only metal having positive electrode potential. Okay. Next question, which of the following statement is wrong? Okay. In highest oxidation state, the transition metals show acidic character. Yes, that is correct. So when a metal is having higher oxidation state, okay, if this oxidation state is very high, it has the tendency to gain electrons, right? And when it gains electron, that is what is the acidic nature. Acidic nature, how will you explain? Gain of electrons, right? So that is why when there is higher oxidation state, they behave in the character is acidic. Next is metals in the highest oxidation states are more stable with oxides than in fluorides. Okay, this is because the oxide has the capacity to form double bonds, right? Yes, so this part is also correct. Then Mn3 plus and CO3 plus are oxidizing agents in aqueous solution. So if they are oxidizing agents, they itself will undergo reduction. What's the electronic configuration of Mn3 plus? Mn3 plus is 3d4. If you make it Mn2 plus, it will become 3d5, which is a half cell configuration and more stable, sorry, half filled electronic configuration, more stable, so that is also correct. Now next one, all elements of 3D series exhibit variable oxidation states. So this statement, if you see the last element, zinc, okay, it has an oxidation state of +2, which is fixed. Okay, it doesn't, so all elements will not undergo. The transition elements will have various variable oxidation states, but not all the elements of 3D series. So the incorrect statement is option number D. Okay, you have to analyze this question. Next question, the incorrect statement in respect of chromyl chloride test. Okay, so formation of red vapors, yes, that is correct. Then you have formation of lead chromate. You know the reaction for chromyl chloride, so that is why there is a formation of chromyl chloride here. There is no liberation of chlorine gas in that. So the incorrect statement is option number D. Next, the species having tetrahedral shape is, okay, here also we have for coordination number 4 two types of hybridization, dsp2 and sp3. dsp2 gives us square planar and sp3 gives us tetrahedral, right? Now dsp2 is generally found when there is a strong field ligand and sp3 is generally found when there is a weak field ligand, right? Now you can just check one more thing, 3D elements can have these two hybridization, okay, but in case of 4D elements and 5D elements, it will be always dsp2 hybridization. Okay, this point also you should remember. Okay, now see, Palladium is a nickel, platinum, palladium. It's not a 3D element, so it will have what? It will have dsp2 hybridization. Okay, so if it is dsp2 hybridization, the shape will be square planar. Now nickel. Nickel is a 3D element, but it is a strong field ligand. Strong field ligand is there. That means it will be having dsp2 hybridization and square planar complex. Now palladium is again not a 3D element, so it will also have dsp2 and square planar. If you see nickel with chlorine, right? Chlorine is a weak field ligand. Nickel is a 3D element, so that is why it will have weak field ligand, so tetrahedral and sp3 geometry. Okay, so the correct answer for this question is option D. Okay, so next last question for this. According to crystal field theory, the Ml bond in a complex is. So this comes under when we study the postulates. It is a purely ionic bond. Okay, so that's all for this video. We have discussed the first 30 questions. In the part 2, we will be discussing the rest 30 questions. So you can just check what mistakes you have done, analyze it, note down the points where which chapter you are weak and what are mistakes you are doing, so that you can not repeat it in the next test. Okay, if you have found this video useful, please like it, share with your friends who all are preparing for your KCET exam, and any question you have doubt, please comment it down. I'll surely address them in my next video. Thank you and all the best.